Calculus, we're going to dig into lesson 7.2 today. We're going to look at volume, and in this first lesson, first part of the lesson, we're just going to be concerned with the disk method. As you can see in the objectives, there's actually several parts to this lesson. You have the disk method, the washer method, and then different cross sections. Okay, so as you saw in the videos, the Khan Academy videos, you saw basically that you're taking your area, chunking it into rectangles, and then revolving those rectangles around an axis of revolution. In today's notes, that axis of revolution is going to either be the x-axis or the y-axis. So these notes start off with just looking at a simple rectangle, and the question below is, what is the area of the rectangle? And you guys know that area is base times height. In this picture, area is going to be W times R. And we use W for the width of your rectangle. We use R for the radius length when we turn this into a cylinder. Okay, so if we go over here, the volume of a cylinder in geometry is pi r squared h. What you're going to be doing is relating that to calculus and the r and the w. So the r becomes capital R for the radius, and the height becomes the width of the rectangle, or the width of that cylinder. This next picture shows you that if you take this curve and you chunk it out into rectangles and you revolve each of those rectangles, you can see that you have a solid of revolution. And if we integrate that with infinite disks, you're going to see an approximation for the volume. So what we're going to do is notice that the formula from before gets brought over to this formula here. So what that's telling you is the change in volume happens to be pi times r of x of I squared. So x of I just represents a particular rectangle, and then times delta x. So that's the change in x. That's actually the width of your rectangle. So r of x of I just represents a particular rectangle. Delta x is the width of that rectangle. And we know that if we were to add up the areas of all those rectangles, we would have the area under the curve. So when you add up all the volumes of the cylinders, you're going to get the volume the volume of the solid. So taking and adding up all the cylinders with summation and limit notation and all that brings you over here to the integration. So basically what you have is you have your volume formula, and we can use their notation. So here's your pi right here. Here is your radius squared, and dx is the same as delta x. That's the width of your rectangles. These rectangles are all going to have the same width, so it's constant. Okay, so we're going to try that here pretty soon. Here are the two formulas that you guys need to know. If your axis is horizontal, this is the volume formula that you have. Now, here's the deal. The rectangle that I had you draw in your last set of homework for 7.1 is very important, because this rectangle, as you can see, is perpendicular to the axis of rotation. So the rectangle is perpendicular to the axis of rotation. So when I see a vertical rectangle, I'm going to recognize this piece here as delta x. If I'm rotating around that axis right there, which happens to be vertical, then my rectangle here is running perpendicular to it, and I'm going to recognize this change as a delta y. All right. So keep in mind that your rectangles are always going to be perpendicular to your axis of symmetry. Now this says in particular x or y axis. Your axis of rotation is not always going to be the x or the y axis. We're going to get into those in the second part of these notes. But for this first part, we're going to just stick with the x or the y axis for our axis of rotation. Okay, so he did a question like this with you in the video. He went from y equals x squared from 0 to 2. And so the first thing we're going to do is graph it. And it says that you're going to revolve it about the x-axis. Now, again, there should be more information here. You need to also have a boundary. So what we want here is just to chop it here at x equals 2. So there should have been more information given to you. Okay, I want you to shade that area. And because you're going around the x-axis, you need to draw that kind of an arrow to show the rotation in that direction. And you need to show your rectangle perpendicular to the axis of rotation. All right, as we set up our integration, volume is going to be pi times a to b of the radius squared. So this is your radius, and your radius is the top of the rectangle minus the bottom of the rectangle. So the top of the rectangle is the curve x squared. The bottom of the rectangle is 0. And then I'm going to square that. And then dx represents the width of the rectangle. So what I have here, if I take all of those rectangles and revolve them, I'll have cylinders. Now I'm adding up all the volume of each cylinder. Now, I don't believe you're going to have any trouble integrating x to the 4th and plugging in a 2. So I'm just going to say that you know how to do that part, and the answer here is 32 pi over 5. Now, if I want to revolve about the y-axis from y equals 0 to 4, I'm going to be graphing the same curve. And I'm going to go from, oops, let me redo that. I did not get the correct ordered pair in there. There we go. Okay, from 0 to 4. So we're looking at this bounded region here again, and I want you guys to make sure that you highlight that or shade it. You're going about the y-axis, so this is your axis of rotation. And remember that rectangle is is perpendicular to it. This represents r. Because this is vertical, that's d of y. Over here, that would have been dx. You get your rectangle by taking the right minus the left, and that's going to be your r. Volume is pi, and then you're going to go from the bottom to the top because you're doing vertical now. Your rectangle, though, is from right to left, and this needs to be solved for x now. So this curve is the square root of y, and then the left side is 0. So it's the right, which is the square root of y, and then it's the left, which is x equals 0. And then I square that and put my dy on there. So pi r squared h. Let's think of cylinders. then again, I don't think you're going to have any trouble integrating that. And the answer we're going to get is 8 pi. Okay, we're going to look at one more of these. And that's this one here. So the square root of sine x, well, that's kind of weird, but the sine of 0 is 0, and it's going to be 0. The sine of pi is 0, so that's fine. The sine of pi over 2 is 1, and its square root will be 1. So it's just going to be this little curve here. We're going about the x-axis, so we're going that way. We're going to be shading. We're drawing our rectangle perpendicular. This represents your r. And so volume is pi times a to b. And then your radius squared. So the top curve is the square root of sine. And the bottom curve is 0. And we square that. This is horizontal, so that's dx. And we're good to go. So volume is pi from 0 to pi of sine x dx. We'll just go ahead and do this one. And the answer there is 2 pi. Coming up in your notes, we're going to, in the next set of notes, revolve around a line that's not the x or the y-axis. And that's where that rectangle is going to be super handy, so keep that in mind. Okay, I'm just going to give you a few problems in your homework to test this out. And that's going to be it for your notes. Have a good day.